Solar energy project writing. Solar energy project writing is an essential aspect of developing sustainable and renewable energy solutions. A well-structured and detailed project document provides clarity, focus, and feasibility on how solar energy can be harnessed effectively. Whether for government proposals, business investments, or academic purposes, writing a solar energy project requires a balance between technical information, financial considerations, environmental impacts, and implementation strategies. This chapter outlines key steps and elements in writing a comprehensive solar energy project document. The first step in writing a solar energy project is to provide a concise yet informative overview. This section summarizes the project's goals, objectives, and scope. The overview should clearly explain why solar energy is chosen as the solution and what specific problems or needs it will address. Key elements to include: project title. Create a descriptive and concise title for your project. Purpose. Explain the motivation behind the project and its significance. Objectives. Outline what the project aims to achieve, for example, reducing carbon emissions, increasing renewable energy usage. Project scope. Define the size, location, and type of solar energy system, for example, solar photovoltaic, PV, for residential or commercial use. Site analysis and feasibility study. The site selection for solar energy projects is critical for their success. In this section, discuss the geographic, climatic, and environmental conditions that make the chosen site suitable for solar power generation. Key points to cover: location. Describe the geographical location and its importance in terms of solar energy potential. Solar irradiance data. Provide data on sunlight hours, solar radiation levels, and seasonal variations. Land availability and use. Ensure that the area is suitable for installation without significant environmental or social disruption. Grid access. Consider proximity to the electrical grid, if the project aims to supply energy to the grid. Technical specifications. This section focuses on the technical aspects of the solar energy project, including the type of technology used, the system design, and the components required for successful operation. Key aspects to include: solar technology. Discuss the type of solar energy system, for example, photovoltaic panels, concentrated solar power, solar thermal, and why it was chosen. System design. Include details such as number of solar panels and their capacity. Inverter types and their specifications. Battery storage systems, if applicable. Grid connection details. Energy output estimation. Estimate the amount of energy the system will produce annually based on local solar potential and system size. Environmental and social impact. Solar energy is considered one of the cleanest energy sources, but any project involving large infrastructure developments should account for environmental and social impacts. Key areas to address: environmental impact assessment, EIA. Discuss the environmental footprint, including land use, biodiversity considerations, water usage, and impact on wildlife. Ensure that the project complies with environmental regulations. Carbon footprint reduction. Estimate the amount of carbon dioxide emissions avoided by using solar energy instead of fossil fuels. Social considerations. Address potential social impacts, such as land acquisition, displacement of communities, or benefits like job creation and local economic development. Financial analysis and budget. A solar energy project requires significant financial planning, including cost estimates, funding sources, and projected returns on investment, ROI. Key financial elements: capital expenditure, CapEx. Detail the costs involved in equipment, land acquisition, and construction. Operational expenditure, OpEx. Include estimates for maintenance, operations, and any ongoing costs. Funding sources. Identify potential funding sources, such as government grants, private investors, loans, or public-private partnerships. Payback period and ROI provide an analysis of how long it will take to recover the initial investment and the expected return. Risk assessment and mitigation. Every project comes with potential risks, and solar energy projects are no exception. Identifying these risks and planning for their mitigation is crucial. Common risks and mitigation strategies: weather variability. Mitigate the risk of reduced solar output due to unexpected weather conditions by incorporating advanced forecasting systems. Technological failures. Ensure reliable technology is used and have a maintenance plan for equipment failure. Regulatory changes. Keep track of changes in energy policies and regulations that may affect project viability. Financial risks. Secure diversified funding and ensure contractual agreements with stakeholders. The project will mitigate technological risks by employing Tier 1 solar panels with a 25-year warranty and setting up a dedicated operations and maintenance team. Weather variability will be monitored using real-time solar irradiance sensors to optimize performance. Implementation plan. A detailed implementation plan is vital to ensure the project runs smoothly. This section should outline the timeline, phases of construction, and responsible parties. Key sections to include: project timeline. Break down the project into phases such as site preparation, equipment procurement, installation, and commissioning. Milestones. Set key deliverables and deadlines for each phase. Stakeholders. Define the roles of stakeholders, including contractors, suppliers, government authorities, and community leaders. Monitoring and evaluation. The success of a solar energy project depends on continuous monitoring and evaluation. Key monitoring aspects: performance monitoring. Regularly track energy production and system efficiency using monitoring systems. Maintenance plans. Schedule routine maintenance to ensure optimal performance and reduce downtime. Evaluation. Evaluate the project against its initial goals, such as energy generation, cost savings, and environmental benefits. The conclusion of the solar energy project document should restate the importance of the project, its potential benefits, and the feasibility of implementation. Emphasize how the project contributes to sustainability goals and the broader transition to renewable energy sources. Writing a successful solar energy project document requires a structured approach that covers all essential aspects, from project overview and site analysis to financial planning and risk assessment. By addressing each component thoroughly, the document serves as a blueprint for project approval, funding acquisition, and successful